Now we continue with our consideration of the reproductive system with a focus on the female reproductive system. And in particular, we're interested in revisiting the stages of the production of eggs, that is, gametogenesis, with this question of how egg production is hormonally controlled. Now, in the last lecture, we talked about how the uterine cycle, the events within the monthly oscillations of events within the uterus, have to be coordinated with the ovarian cycle. In particular, menstruation needs to not occur when ovulation and the potential fertilization during the luteal phase occurs, that's controlled by the ovaries. So the timing of ovulation here needs to not occur during menstruation here. So we're going to talk about that control, and I already mentioned that it's complicated because it has to regulate the change in both of these regions, the ovaries and the uterus. And we'll also see that there's a role played by the central nervous system. Okay, so within the ovaries, there is this structure around each egg called the follicle. And there are two cell types that I previously mentioned as being important in control, and they're called the thecal cells and the granulosa cells. So the thecal cells are the ones that are most superficial in the follicle. Okay, or I should say that they're more superficial than the other one, because we still have an epithelial lining. Anyway, the thecal cells are pretty superficial. Now, what I'm going to do on the right is draw a control diagram, and I've removed the set point and the error symbol. We can just assume that within this diamond shape, we have all of those parts. There's also afferent parts because the thecal cells and the granulosa cells are both capable of sensing hormone concentrations. So there's a lot packaged in that little diamond, and the reason why I'm doing that is because you'll see that the control system gets really complicated with multiple integration centers. I believe there's a total of 5 of them. And so just in the interest of space, we don't detail all those other parts. Okay, the thecal cells, the first thing you need to know is that they secrete hormones called androgens. Now, the granulosa cells take those androgens, and the granulosa cells are more in the interior, closer to the egg and surrounding the egg. The androgens are converted by the granulosa cells into estrogens, and this makes them have a you could think of that as sort of activating those chemicals so that they can influence both the central nervous system and the uterine lining, the endometrium in particular. The estrogens stimulate the production of the endometrium. Not only that, but the estrogens feed back on the granulosa cells themselves. So in this respect, they provide a positive feedback loop, which drives the proliferation of the endometrium. And this occurs in the wake of menstruation. So we have, at this point in time, this rapid development and really the stimulation to rebuild the endometrium. This is after the period, and the goal is to essentially create a hospitable environment in the uterus for an implanted zygote. Now, where I've mentioned the brain and the central nervous system, where are we talking about? Well, we've already discussed the interplay of the hypothalamus with the posterior pituitary when we were talking about the control of water balance in the body. Now we've got a similar situation in that you have a region of the pituitary that secretes hormones, but in this case it's the anterior pituitary. And so the hypothalamus has networks of neurons that project into the pituitary, and then the pituitary is a secretory organ that releases hormones. So similar to what we saw for osmoregulation. In this case, the hormones that are released are called follicle stimulating hormone, FSH, and luteinizing hormone, or LH. And so we've added another integrating center, the anterior pituitary, which receives commands from the hypothalamus. And in response, that region releases FSH and LH. So given the name, as you might expect, follicle stimulating hormone, in females anyway, stimulates follicles. And in particular, the granulosa cells are responsible for that follicle growth, which we see there. Now, I mentioned that the anterior pituitary receives signals from the hypothalamus, and in this case, it's a hormone released by the hypothalamus that is received by the anterior pituitary. And that signal essentially tells the anterior pituitary to release both FSH and LH. And the hormone that's released is called gonadotropin releasing hormone. So FSH and LH are both considered gonadotropins. And the hypothalamus releases GnRH essentially to stimulate that release of FSH and LH. Excuse me. Okay, so when we look at the concentration of these hormones in the blood, then we can begin to get insight into how they control both the uterine and ovarian cycles. So first of all, FSH, the follicle stimulating hormone, is it's sort of oscillating a little bit at this early phase. So this is, if you'll recall, before ovulation, it's called the follicular phase in the ovarian cycle, and then we had the luteal phase later on. So this is early on in the follicular phase. FSH is not particularly interesting, its oscillations, but what you need to know is that this is actually an intermediate concentration. So this level, and we'll see because it dips down later, but this level does stimulate this enlargement of the follicles that occurs, which is necessary before ovulation. Okay, so this is a non-zero concentration that it's meaningful for stimulating the follicle growth. Now estrogens are products of this positive feedback loop that is fed the androgens. Okay, so it's not like an out of control positive feedback loop with a necessary shutoff because it's limited by the availability of androgens. Nonetheless, we do find that there is something almost like exponential growth in this period of time of the estrogen concentration because of that positive feedback loop, which is driving proliferation. So you can think of estrogens at this stage as creating that development of the uterus that I mentioned, and that's reflected in the concentration change. Now, as we'll see, estrogens they're multifunctional. They have multiple roles here. This is just the first. All right, so we're going to step through time up to the events that precede ovulation. So we're in late follicular phase here. The estrogens begin to top out. The androgens are phased out. We can see them sort of declining there. The estrogens at this stage have an effect on the hypothalamus. All right, so now we begin to see the sex organs feeding back onto this region of the brain, and we add that. That's going to stimulate greater release of GnRH, gonadotropin releasing hormone, which fuels FSH and LH to increase. So we first see an increase in the follicle stimulating hormone. Another hormone that becomes important in the luteal phase is called progesterone. Progesterone also increases at this point in time because it too, like the estrogens, are generated by the granulosa cells. All right, so what is progesterone good for? Well, estrogens did stimulate the initiation of the creation of the endometrium in the uterine cycle. Progesterone is a necessary signal to maintain and grow the endometrium at a more gradual level. So when we enter into the luteal phase, we'll see that the maintenance and building of the endometrium is progesterone dependent. And we know that because when progesterone drops, then that triggers menstruation and therefore a breakdown of the endometrium. All right, so we'll call that maintenance. The progesterone maintains the endometrium. Not only that, okay, so you can see how things are getting complicated on our control system. And that's okay. It's a control system that changes over the course of a month. The progesterone, like the estrogens, feed back onto the brain, and they act both directly on the anterior pituitary, which drives more FSH and LH to be produced, and it also works on the hypothalamus to release GnRH, which does the same thing. It stimulates the anterior pituitary to release these hormones. Now what occurs is now we have two positive feedback loops. And you can see that the hormones that I've already detailed on the left are all rising in response to that. So that's not a big surprise. And there's a final hormone here that we can see as getting the greatest increase up to ovulation, and that's known, or that is the luteinizing hormone. Okay, the luteinizing hormone drives ovulation. It is the key signal to tell the ovaries that ovulation should occur. And in particular, it's the thecal cells that are the target of LH, which we see in our control diagram. That's not too surprising. But the thecal cells are good for more than just producing androgens. They also drive ovulation. Ovulation itself has positive feedback on both the anterior pituitary and the hypothalamus. Okay, so there's a lot going on the right-hand side of the control diagram up to ovulation that drive that positive feedback that we see reflected in the LH. And then ovulation is the event that that results from that building up of all of those hormones. So what occurs during ovulation? We have a bursting of the follicle. There are high-speed videos of this event. It's very forceful, and the egg really does shoot out from the follicle, which bursts the follicle, and I mean that's a rupture of that structure. The release of the egg is then captured by the fallopian tube with all of its cilia that can begin to propagate the egg through the fallopian tube. So the follicle then becomes the corpus luteum, or we'll refer to them as the luteal cells, this little sac that eventually disintegrates to nothing. And this rupturing, this event, and the transition of the follicle into the corpus luteum has control implications, because essentially what we had was these granulosa cells and thecal cells within the follicle that were they're very intelligent cells. They're monitoring the blood for the concentrations of FSH and LH. They're making decisions about what to release in response to that. After ovulation and as we enter into the luteal phase, then these integration centers become feed-forward agents that are insensitive to FSH and LH. So that essentially ruptures the communication between the brain and the sex organs. So this last step here is really important control-wise. And so what we're going to do to our control system is replace GH and TC with the luteal cells. Okay, that's what's within the corpus luteum. The luteal cells are feed-forward actors that merely secrete estrogens and progesterone. So we see that in the control diagram on the right. On the left, we can see that initially there is a drop and then eventually an increase in estrogen and progesterone that's provided by the luteal cells. Now we can also see that there's a change in the control properties of the brain. So ovulation really wreaks havoc on all of what we laid out during the follicular phase. The luteal phase, everything is kind of different. So instead of having a positive feedback like we see here of estrogens and progesterone on the brain that would cause an increase in FSH and LH, what happens during the luteal phase is they have a negative effect on the brain. Now, the exact mechanism of this I am not totally sure of, but take my word for it, they have a negative feedback. And the way that we know that is that despite these oscillations in estrogen and progesterone, when you look at the concentrations of FSH and LH, we see that they plummet to a very low level. So here I mentioned that FSH initially was at a non-zero level. You can see here that it drops to a lower level during this luteal phase. Okay, so there's a lot to unpack there. We've got the luteal cells providing estrogen and progesterone during the luteal phase, and they have a negative effect on these brain centers. Now, another thing is that eventually the corpus luteum will die. So if fertilization doesn't occur after 12 days, then it dissolves to nothing. That is, after this peak that we see here in the concentration of those hormones. So what occurs next is dependent on fertilization. If there's no fertilization, then we see this drop off in those hormones because the corpus luteum dissolves away and fails in its ability to maintain those hormones. Because those hormones, estrogens and progesterone, are having a negative feedback on the hypothalamus and the anterior pituitary, once they get to a sufficiently low level, then we begin to see changes in FSH and LH, and a rise in FSH in particular. So what's going to happen there is that as FSH is now released again, it's going to stimulate the development of a new follicle. Now, at the same time, the drop in progesterone, because the endometrium is dependent on progesterone, and progesterone is the dark red up here, when progesterone drops, then that is going to trigger menstruation, the period. Okay, so that's what we see is that the stimulation of the period as a new follicle is being stimulated by FSH. Okay, so we're repeating a little bit here. So we have the generation of a new follicle. Okay. Now, all of this plays out differently if fertilization occurs. The goal with fertilization is to maintain the endometrium so that the zygote can implant on the wall of the uterus. Okay, so what's going to allow that to happen is the maintenance of progesterone. If the progesterone remains high, then the uterus will maintain the endometrium. Okay, so if we look at that scenario, so if the egg is fertilized, then fertilization, first of all, triggers the corpus luteum to be rescued. If the corpus luteum remains, Then we have the luteal cells generating progesterone, and we actually see an increase in progesterone there. That also feeds back negatively on the brain centers, including the anterior pituitary, which inhibits the release of FSH that would act on the granulosa cells. So FSH maintains at a low level like that. And we do not have the generation of a new follicle as a consequence. Now, eventually, over the course of embryonic development, this all changes. The goal is still to maintain progesterone at a high level, and estrogen as well, so that it has a negative feedback on the hypothalamus. But eventually that role is taken over by the placenta. Now, this is also, by the way, what birth control pills do. They essentially trick the body into thinking that it's undergoing pregnancy through their different formulations, but you can imagine here that if you have a pill that has progesterone and estrogen, then it's a signal for the brain to not generate FSH to create new follicles. And the progesterone concentration itself directly signals to the uterus to maintain the endometrium. Now, you can still have your period on the birth control pill, but it's supposed to be lighter and result in fewer cramps. And that's why some folks are prescribed birth control pills just as an antidote to menstrual cramping. So that's the aim of the birth control pills, is to essentially simulate the conditions of a pregnancy. All right, so we've covered a lot. Let's summarize what we've gone over here. We have the early follicular phase, where estrogen feedback drives proliferation. We see that reflected in an increase in the concentration of estrogens. At the same time, GnRH and FSH are stimulating the growth of the follicle, in particular FSH. LH will play a role later in stimulating ovulation. In the late follicular phase, we have progesterone maintaining the endometrium. So again, estrogens get it started, progesterone takes over for maintenance. That maintains the endometrium to the point where the endometrium depends on a consistent supply of progesterone. Ovulation occurs through positive feedback loops to the brain centers of the hypothalamus and the anterior pituitary to create an LH surge, which acts on the thecal cells to drive ovulation. Then everything changes during the luteal phase. The luteal cells produce progesterone and estrogen. The estrogens then feed back to inhibit the hypothalamus. The progesterone does that as well, in addition to having a feedback on the anterior pituitary, and perhaps most importantly, it is the signal to maintain the endometrium. So we have that negative feedback, which inhibits the release of GnRH. In the late luteal phase, we have the breakdown of the luteal cells unless there's a fertilization, and the lack of progesterone triggers menstruation, and the lack of GnRH inhibits the stimulation of follicle growth via the follicle stimulating hormone.